through various components inside Kubernetes. I think we are slowly learning many components within Kubernetes. I think just to give a quick recap. So I think we looked at what is cluster, and in cluster we create multiple nodes, and there'll be a master who is also called as control plane, and of course there are nodes who are worker nodes or minions or also called as nodes. So these are all nodes which talk to master. So and it generally in a typical Kubernetes cluster, there will be minimum of 3 nodes. So just in case if one goes down, there is a two other nodes are there. So minimum is 3. Of course, you can also create a 1-node cluster also. It is possible, but it's really not solving the problem. So it could to have is minimum is 3 nodes, and of course you can also have n number of nodes also. And there are instances where there is a competition in terms of organizations here who runs the biggest number of clusters. For example, Alibaba runs billions of clusters of Kubernetes clusters for their organization and for their portal, Alibaba websites, and also so there are a lot of claims in terms of who has a lot of biggest Kubernetes clusters in the world. So yeah, some competitions are going on also as well. So but yeah, the idea is like you can create billions of clusters, billions of nodes inside each cluster. So it is also possible, and that's where Kubernetes and in fact Google, who is using these clusters, so they are Google of such scale. If they can use and they are already using this, then definitely the scalability is never a doubt on this Kubernetes clusters. So yeah, so summary. Kubernetes cluster will have a control plane and there will be multiple nodes which talk to the master. And control plane does many things, so which are hidden mostly for us, but control plane has a lot of automation logic is all there in this control plane, which can take care of activities like scheduling the applications, maintaining the applications for matching the desired state, scaling the applications, and rolling off the new updates and all these things. So whatever is the commands that we saw behind the scenes, everything is done by master. Whatever commands we say, I need 3 replicas, then it is giving you 3 replicas. If you delete a pod, it is bringing a new pod. So all this magic is all happening inside, are done managed by the control plane. And of course, this control plane will talk to the nodes and get that work done. So that's about the Kubernetes cluster. And then we also saw Kubernetes deployment. So whenever you want to deploy something, so you all communicate everything. All the communication should go through the master. So master control plane. So you give instructions to the master, and master will ensure that that instruction is executed into the one of the nodes or all nodes. So for example, when you create a deployment, that's where you tell what is your pod and what is the image that you need to use. For example, if you look at this command, kubectl create deployment and some deployment name, hello world REST API, and image is the Docker image that I uploaded in my Docker Hub. So if I execute this command, actually when I execute this command, you're giving instructions to the master, and master is creating, it sees that this is a deployment component, and I need to create this, it scans what is the image that you're asking to download or use. So, and then it will download that, it will give instructions to the node, and node will execute the job. So node will, if this image is not already there, it will install that image, and it will run that on this machine, so on this node. So that is the deployment. So basically, we're giving instructions to the master, and master is executing that operation. That's about the deployment. And we also discussed about the pod and nodes. So pod is the smallest unit in Kubernetes. Pod is few things to remember. Pod is something, it has an IP address associated, and pod could be more than one container images. So like group of 1 or more application containers plus shared resources, and this is the smallest unit in the Kubernetes. So if you take all these are pods, for example, but you see the size. is single one pod, and pod with one container image. Pod 2 probably with shared instance, shared storage. Um, Same thing here, two pods, one small pod, one big pod with shared storage, and many pods here. I mean, not pod. I mean, what should this is all container images. So small container, multiple container images, and multiple shared volumes as well. So yeah. So summary, you can consider this. Keep this in your mind as a picture for pod. So pod can have multiple container images and also multiple storage volumes. So, so this storage resources or shared resources are basically it could be storage, it could be networking, or it could be info about how to run these containers. For example, if there are multiple containers, how to run them. So that metadata information is also shared resource. So summary, pod is equal to a group of multiple containers plus shared resources. The shared resources generally are storage, networking, or metadata in terms of how to run this container. And one important thing that you need to know is this is also having an IP. So they share IP. But if you look at the IP is associated to a pod, not inside a container. So it's associated to a pod. So even for this bigger picture, a pod is I mean IP is associated to a pod, and this IP will be shared by all the other container images inside this. So how do they communicate with each other? I mean, there's a lot of things Kubernetes does in the networking space. I think we'll cover the networking more in deep dive. But for now, networking aspect is there are many things behind where you don't see it, but I think it does many things. I mean, I was just reading the networking section, and I really see the value of what Kubernetes is offering. But I think networking is, if you look at all these pods, they could access each pod, each container images inside a pod. They could reach each other via localhost. And also, if you are associating, if there are multiple pods inside a node, and each pod also can talk to other via localhost. So I mean, generally localhost meaning 127.0.0.1. So they can access it locally. So as if everything is running inside one laptop, you can access application A and application B via localhost. Same way. So basically IP addresses, I think we'll go to the networking section to understand there more. But I think for now, what you need to remember is pod has an IP associated, and also it uses ports. So basically you can access a particular pod by IP:port to access that. So let's say if it's a web application, you can access that using IP:port. Right. That's about the pod, and also also if you look at node is again nothing but this guy is a node, so virtual machine. So this node, so where does this pod reside? The pod resides in a node. So node in a node there could be more than one pods like this. For example, as you see in this diagram, there could be more than one pods that can run. So how each pod is identified? I mean, there is something called selector, which I will explain later in the slides. But there's something called labels that you can associate. So that every time when service is calling this pod, it will look at the labels to identify which pod to call at any given time. So basically, two things you need to remember: for every pod, there is something called label, and also there is something called IP. So right. So a node is worker machine, which is managed by a control plane, and pod runs on inside a node. But generally, the hierarchy is there will be a node like this, and there will be multiple pods inside this, and each pod will have multiple containers like this. So that's a hierarchy. So one node can have multiple pods, and each pod can have multiple containers. So right, and then node also has something called kubelet. If you see here, text is not very clear, but probably this is kubelet. Kubelet is again a component. It's a Kubernetes specific component. These are some pre-built installations that will happen when you set up Kubernetes cluster. this kubelet is a small component which will be auto installed on a node. And this guy is like, you can imagine, a batch job who is monitoring the status and who will be always sitting inside your node and monitor it and gives the status to the master. So someone should give status of this health information to master. It's how master will know. So this kubelet is doing their job. So the kubelet monitors and gives the details back to the master. So and this node also has since we're talking about using Docker images, I mean, these are all container images, which means you need to have some container runtime also. So Docker is one container runtime that also has to be installed on the nodes. So these are two components that will be there in the node. Apart from your pods, a node will also have kubelet and also called a container engine. Here it is Docker. But Docker is not the only container engine we discussed earlier. There are other container engines like CRIO, CRIO, likewise a lot of container engines are there. But of course, Docker is the most popular container engine. So summary, pods will have IP address, and it is possible to have more than one images, and they share common stuff like storage, networking, metadata, and multiple pods reside in a node. And node generally will have a kubelet and also a Docker or a container engine. So which will help to run this container images, right? That's about pod and nodes. And also we discussed about service and labels. So imagine how there are multiple nodes, so if in a node there are multiple pods, but let's say you want to call this pod only, for example, 10.10.10.1. So how will you call that? So again, this pod says, I mean, this is all ephemeral, so this can die down, and every time it dies, it gets a new IP. So it's always not good idea to use this IP address to call a particular pod. So generally, the good practice is to have something called service. So the service will give you a static fixed IP and DNS, and you call that service, and service will internally does the magic in terms of identifying which pod to route the traffic to. And how will it know? How will it route the traffic? It is through labels. The labels, as I said, it plays a very important role in the Kubernetes world. So every there are multiple pods. The service will send the traffic to particular pod by looking at the label that was linked. So let's say you want to send the traffic to label app is equal to A. Yeah. So you need to already create prior to that, you need to create these pods with app is equal to A, so that it knows that there are 3 pods with labels app is equal to A, so that whenever traffic comes, service will route the traffic to the respective pods with the same label. So that's how this labels play important role in service. And also if you look at this something called replica set, RS. Replica set is something which will ensure that there are multiple instances of pods are running. So that is what is replica set's job, is to ensure that if you say replica is 3, it will always ensure that there are 3 pods are running. So and also a deployment is where you give all these replicas, how many replicas you need and how many pods you need. All this information you specify in a deployment file. So yeah, so that is the beauty of this service and labels. And also we discussed about the rolling updates. This is one of the very popular design pattern that Kubernetes offers. Again, but this is one of the deployment strategy. And of course, you can override this also. But if you're not giving any deployment pattern, Kubernetes always picks rolling update as the deployment strategy. I mean, rolling update is a concept where it will, at any given time, it will not blindly, if you want to deploy, let's assume there is a version A that is already deployed. Let's say this is a service which are in blue color, this is green, right? Sorry, green color. The service A is already running in a 3-node cluster. And now this is version 1 of your project, and let's say you want to roll out version 2 of your project, of your latest code that you have. So introduce some feature and you want to deploy that version 2. So when you deploy version 2, by default, since Kubernetes applies rolling update pattern, it will not bring down all the version 1 and redeploy version 2. It will not do that. I mean, this is a production deployment process where generally we do that, right? I mean, in a typical production, when I'm talking about a non-Kubernetes scenario, the practice that is followed in olden days, even now, many people do still this. Whenever you give a latest code and ask someone to deploy it into production, they bring down the older application, deploy this new change, and then bring it back, right? To bring the everything instances back. But I think the problem with that is there is always a downtime, momentary downtime that will be there. The downtime could be minutes to hours, for example. That's why generally the production deployments all happen over the weekend, so that the impact is minimal, or over the late in the night. So, but in rolling updates pattern, so you don't need to worry about that downtimes because this will be a gradual deployment. So it will not be deployed, it will not be brought down, and then it will not deploy the new ones. So it will follow a gradual deployment. That's why it's called rolling update. So it's like gradual deployment where first it will deploy your version 2 first, and then it will uninstall the version 1 from the node 1. But node 2 and node 3 still use the older version. So and it will monitor this momentarily, and it's good. Then it will start gradually deploy the other instances also in other nodes, and then slowly undeploys the version 1. So at the end of it, probably at the end of 5 minutes, let's say I'm just giving an example, random time, but at the end of first minute, it will deploy this new version, and it checks it is working fine. Then it will slowly deploy others. Probably in a minute in 5 minutes, I think you will see all this latest version deployed. So this way, the traffic that is coming in during this process, right? So momentarily, the traffic might go to old and new, but I think that is very momentary. But the advantage in this pattern is that you will not there is no downtime. There's no real downtime. So at any given time, the traffic momentarily will be either traffic will be routed to, let's say in this case, when the traffic is coming from client. So depending on what load balancer decides, either the traffic will move to version 2 or version 1. So there will be version 2, version 1 conflict could be there, but I think that is momentary, so that's fine. But there is no downtime as such. So that is the advantage of this rolling update pattern. I think we saw this live also as an example. So I think we learned many things. I think in Kubernetes. So let's collate everything together. So with this, I will go to the Kubernetes architecture. So I mean I'm taking this architecture as a backseated version. I'm giving you generally in all the other platforms, learning platforms that I saw, they directly show you the day one they show you the Kubernetes architecture. So I mean it is there will be so many components and it will be confusing. So I'm slowly introducing you in a day 3 so that by now you understand what is control plane, what is node, and what are the various components inside. Now if I show you this, you will understand this or appreciate this better. So this is the Kubernetes architecture. So as we saw here, right, in any other slides before, I think there is a master and there is a nodes. I think this is what I depicted in a different diagram there. So this box is what is master, and these 3 are nodes. So that is what is here. This is control plane or master, and these are the orange boxes are the nodes. So every time you interact, when you run a kubectl command, so actually you are interacting to the master. In that, especially there are in master there is a component called kube API server. So this is the component there where you are talking to, and just I think there was one question someone was asking. I think maybe Jnani, I guess. I'm not very sure, but I think every time you give a command, what is happening behind the scenes? So actually, what is happening behind the scenes is the CLI commands. These are called CLI commands. The CLI commands are getting translated to an API call behind the scenes. Of course, you can call directly an API as well, but API it is not very easy, right? I mean, it's calling and invoking an API. You need to is not user friendly. So command line is user friendly. So that's the reason Kubernetes team they picked up command line as a most commonly used tool. Of course, there is a UI component. You can also use UI, Kubernetes UI, and also there is an API component. You can also use APIs. But generally the command line option is what is most used in Kubernetes. But whatever. So this internally everything is API driven internally. The command that you give, the kubectl commands, it actually you are giving. I didn't depict that here, but as a user, if you're sitting outside and you're giving some Kubernetes instructions, so it is actually you're talking to the master, and that master control plane, and then you're talking to Kube API server, and this Kube API server gives all the instructions whatever you give to the nodes, and actually the pod, the deployment that you're creating is actually deployed here. The pod is created here and the container inside pod. So we're creating the pods inside the nodes. So you can imagine these nodes as virtual machines, 3 virtual machines talking to one master. And these 3 virtual machines, whenever you ask you to deploy, create a pod, it is creating these pods in all these 3 nodes. Right? Okay, so let's go to the master first to understand what are the various components inside a master. So I mean, this one thing, this control plane or master is same. So I mean, wherever I use switch these terminologies, yeah, both are same. Control plane and master is same. So this control plane, if you look at the components, Kube API server is one component we just discussed. All the instructions this guy is the front face for everything master. So the UI talks. I mean, there's a Kubernetes UI. I will show you that Kubernetes UI shortly. But there's a Kubernetes UI which also talks to Kube API server. Command lines that you give also talk to Kube API server. So this is it's like he's a public figure. So this guy will talk to the external world and give instructions to the internal guys. And this Kube API server has a mini database called etcd etcd. Again, this is a NoSQL DB which stores the health of all the nodes and all the cluster information is all stored in the etcd database. So that's how it knows at any given time who is my node and what is the status of the nodes and how are they connected, how they're healthy. All that information is all maintained in this etcd DB, right? Again, this internal DB where it is not exposed to outside world. I mean, it is something Kubernetes internal DB. So of course, if you're administrator, you definitely can access it, but not for it's not for developer. So it's internal component. And then this Kube API server, it just the scope of Kube API server is just to accept inputs and ensure that functionality is executed in all these nodes. And of course, it maintains the state in this HDDB. But when you say which node this pod has to be deployed, so that decision, there are 3 nodes are there, and there could be hundreds of nodes also, as we discussed. So in which node this pod has to be deployed out of 3, which pod, which this pod has to be deployed in which are nodes. It could be 1 node or 2 nodes, or it could be all 3 nodes. So that decision is done by Kube Scheduler. Kube Scheduler is another component within master, and this guy will talk to a Kube API server, because Kube API server is the one who gets all the instructions. So this guy will get the inputs from Kube API server, and also this guy will instruct Kube API server since the instruction is to create 3 pods. You deploy 1 pod in each node. So that is my decision. So that information is passed to Kube API server. And this Kube API server will again give the instructions to the kubelet in this node. Hey, this is my decision. So you install one pod in each node. And according to that, instructions will be followed. So yeah, so this kube scheduler is one thing that we should know, and kube scheduler is something generally it is intelligent in scheduling the pods in a right way, but sometimes if you have specific requirements, so you can instruct that requirement also. So the kube scheduler follows that instructions. If you're not giving any instructions, it will take addition on its own. So I think there is a recent incident which I want to discuss is there is a very common use case where the database, right? So as part of pod could be anything, like pod could be a DB also. So the pod we want to deploy. So the pod that we wanted to deploy for a DB. So we have specific requirement where this pod has to be deployed in a node which has a solid state drive, right? The nodes are nothing but virtual machines, right? So you can, so this virtual machines, just like a laptop, will have a solid state drive or some drive. So let's say I want to install this database pod on a node which has solid state drive. That is my requirement. So then, but there are other nodes also with me which doesn't have a solid state drive. So then I want to enforce the Kubernetes to tell that you have 3 nodes, but only one node has solid state drive, other 2 nodes doesn't have solid state drive. Then I'm enforcing Kubernetes to deploy this database pod only on the pod which has solid state drive. So that kind of specific requirement, if you have, you can give that instruction, and kube scheduler will execute that. So otherwise, if you don't give that, it will follow its own default. Right? It will not check and it will randomly assign the pod. So that is about kube scheduler. And the next one is controller manager, cloud controller manager. This is an optional component. If you are using cloud as your Kubernetes environment, then this cloud controller will ensure that it talks to the respective cloud component. In this case, in the demo that we saw last time, so for example, the load balancer and also the nodes, we use Google GCP as our component. So cloud controller manager is the one which is talking to the cloud APIs of Google, and it created the nodes on Google Cloud Virtual Machine, and also the load balancer also is created on Google Cloud. Right, so that is the role of a cloud control manager. But again, this if you are setting everything on premise, this doesn't have any role. Then next is this kube controller manager. So this kube controller manager is the one which controls the pods. So in terms of the scheduling or replicas, so those details are all how many instances we need. So this kube controller, let's say if you're giving replicas as 3, so this kube controller role is to ensure that there's always 3 instances of a pod is running. If that is not, then kube controller will inform kubeAPI server, and then kubeAPI server will give instructions to kubelet, and kubelet will ensure that one pod is died, so you add a new pod. So that is done by this kube controller. So basically, if you look at every job is segregated. So there is one guy who maintains the important pieces. So again, you can imagine that this control plane is also like microservices. So each microservice is doing one job, right? So internally, Kubernetes also follows a microservices pattern. So right. So that's about the control plane. So control plane does all the heavy duty. It starting from getting instructions from outside world, scheduler, that is what is kubeAPI server, and it's not getting outside from outside instructions will be accepted, and also it will give instructions to the inside guys. Like this is the only guy who will talk to the nodes also. So none of these components talk to the nodes. Only kubeAPI server module is the only one which talks to the nodes. It especially talks to the kubelet and kubeproxy. So that's about this master. So if you look at master does a lot of things. It is accepting inputs, translating that to the nodes, and it maintains the state in HT, and the scheduler will ensure that the scheduling is done properly. I mean, the pods are properly installed on specific nodes. That is scheduler, and if you're using managed services of cloud, so this cloud control manager will do this. Will ensure that Azure or Kubernetes or Azure or AWS or whatever, Google. So whatever cloud you're using, it talks to the respective cloud components. And also this kube controller is the one which ensures that the necessary instances are available at any given time. So replicas, for example, how if you gave replicas as 3, it ensures that 3 is already there. So yeah, that's about the master. Any questions in master? Okay. So yeah, I think that is what is already highlighted here. This Kube API server is the one which ensures that it validates and configures the data for the API objects, acts as a gatekeeper for the entire cluster, and communicates to the external world. So that is what this API server does. So it is a in politics. I mean, you have this speaker, right, or I don't know what do you call it, a person who speaks on behalf of the party, right? So he's the one who gives all the instructions to the outside world. So that guy is this. So this guy QAP server will ensure that all external world talk to this guy. So and a scheduler, as we have just discussed, it schedules the pods across multiple nodes based on the resources that are available on the nodes. So yeah, this is one important point. So this kube scheduler, it not randomly does the allotment. So it looks at multiple things. For example, in terms of how many resources are available in the nodes, for how many CPU, what is the CPU, and what is the storage, and all those things. To look at the capacity of the node in terms of how busy it is, and then it will always ensure that a pod is installed on a node which is having less resources, right? So that way there is load is balanced. So that is what this kube scheduler does. And next, going to this controller manager, I think we just discussed this controller. The last one, the control manager coordinates the entire clusters and monitor the health of the nodes and the pods that are running. So it will always ensure that you're telling that you need 3 pods, always 3 pods are running. So and also it monitors the health as well, health of all the nodes and then the entire cluster. So based on that, it will make a decisions who is active, who is inactive. If anyone is down, bring a new one. So that kind of decision is done by this controller. And of course, cloud controller, which interacts with the cloud resources. HT is a key value data store, central database to store the cluster state, single source of truth of master and node state. So all this stuff is all maintained in HT. That's about the master. If we go to the node, right? I think node is
which is like a brain here.
Master is a brain, of course. So master is a brain, but brain has multiple components inside. So I mean, each has a specific role to play. So, but if you look at the brain is QBAP server. If you see all the arrow marks are all talking to QBAP server, and also the outside guy, if let's say as a user, if a developer, you're also giving kubectl commands, though that is also going towards QAP server. The QAP server is definitely a superpower in this master because all talks to QAP server, and QAP server gives instructions also to the nodes. So this, yeah, I mean, in terms of the role it plays, QAP server is a critical component inside a master. Right.
Yeah, so they looked at the human system and replicated.
yeah. So I mean, it has a limitation. That's why this database is also added to this. So this is like it stores the status, health, I mean, it stores it's like central database of all the cluster state. So cluster, when I say cluster, I mean, I'm talking about the master and also the nodes. So all together, all information is stored here, and it's just a single source of truth for all the master and the nodes. So in terms of health and other aspects, so everything is stored here. So yeah, but that's why this is the only component which has a DB component. The rest of it also doesn't have a DB. So yeah, right. So that's about this master. But if you next go to the node is very simple. Node, I mean, that's I mean one thing to add again back in master before I forget. So this control plane, since it is doing most of the job, right? That's why there are a lot of components involved in setting up this master in an on-premise. Let's say if you're playing a role of a Kubernetes administrator, right? So and if you're doing an on-premise setup, setting up master is the toughest job. I mean, because it has many things. That's why all these cloud players take this pain of setting up this and giving you a managed Kubernetes control plane. So that's why I mean you can definitely it can be done on local, but on the on-premise also. But you need to take care of many things in terms of the resources for your control plane. What if control plane itself goes down? I mean that is a core epicenter of your Kubernetes. So what if at the end is also a virtual machine, right? So you're installing all these components in a virtual machine, and what if that master itself goes down, right? So that is those are small administrator things that on-premise you have to manage many things beyond Kubernetes. So that's where managing Kubernetes is not easy. That's a very popular statement still. Managing Kubernetes, setting up is also easy, but managing Kubernetes is not easy. So okay, day one you set up, but day two, day three, day four issues are very important things, because if master goes down, everything goes down, right? So there are some design patterns around maintaining replicas of master also. I mean, create a backup of master. If primary master goes down, backup master will pick up. So all those, there's a lot of design patterns around master, but that's where this cloud shines, right? This cloud has a lot of managed services which can help you to take away that headache. So it is a job of Azure or a Kubernetes or a Google or AWS headache to manage this master. And if you're going to manage Kubernetes services from Google or AWS, you will not have access to any of the master nodes. Master nodes is completely hidden from you because that's completely managed by the cloud, right? So you can in cloud you can only access to the worker nodes, not the master. Master is completely managed by because they have to manage this on your behalf, right? So if they give access to you or me, so and we can change anything, and they will not. If something goes down, then yeah, there is SLAs all will come into play. That's why they don't give access to you to master in cloud. So all you manage is you just create a cluster. I mean, even the example that we created now, so we just created 3 nodes, but master we just selected what Kubernetes version we need. That is the only thing we selected from master point of view. It's all done by the nodes. I mean, we just created nodes. We have complete control on the nodes. You can connect and you can do whatever you want in nodes, but not master in cloud. So that is one disadvantage or whatever you call. So yeah, in cloud you'll not get you'll not be able to access to this node where master is running. Right, and then let's understand node. What is node? Node, what components are there inside node? So node is nothing but again another virtual machines. So the nodes have various small components, like I think we already saw this kubelet, which in fact talks to the kubeap server or master. The kubelet is a small agent. It's just like a batch job. I can imagine a small agent that runs on each node. Okay, and provides the health details of each node to the master or control plane. So it is just like a sidecar container. I mean, this is a term again specific in Kubernetes. Sidecar container is is one design pattern. Sidecar container is like some small batch job which is running, is another Docker image which is running inside every node, and it will monitor the health and pass the details back to the master. For example, if you see here, this information is passed back to the master and it transmits to Kubernetes server, and it stores the health of the information in the HTTP. So at any given time, what is the node, what is the name of the node, or what is the resources, what is the health, everything, Kubelet gives that information to Kubernetes server, and Kubernetes server stores that in HTTP. So that's how Kubernetes server knows at any given time who is my node. Okay. So that's the role of a kubelet. It's just health information passage. That's all. That's kubelet. And proxy. This is one of the very critical component in the node. This is the one which, from the name proxy, you can say it's a networking component. So this is another Kubernetes component which is installed in a node, which will actually give the IP addresses for every pod that is set up. If you remember in this diagram, we saw every pod will have an IP address, right? Every pod will have an IP address. So and these pods are sitting inside a node. So everyone has an IP address, but who is giving this IP address? So that in a node, node itself has an IP. Node is nothing but a virtual machine, right? So it has an IP address, but inside the pod, they also have an IP address. So that IP address or networking stuff is all managed, created by this kube proxy. So this kube proxy does play a role of a networking component, and primarily it manipulates the IP tables. Again, this is a networking term where it's a repository of what is the source and what is the destination, what should be the IP address. So it maintains IP tables on each node, so that one pod can talk to another pod, and one node can talk to another node, and also exposes the services. So as I said already in this diagram, right? So each pod can talk to other pod, right? So a pod is basically in one virtual machine. You can imagine your laptop, right? So your laptop can have an application A you installed and application B you installed. So and application, since both are running on your local laptop, right? Both can access each other, meaning from this application you can access this application via localhost. Or an IP address 127.0.0.1, so which is standard. So you can access all this. The networking components between these two is all managed in your laptop or any operating system. There's something called IP tables. The IP tables will have the details of who can talk to whom. So that that is all maintained in this the networking component of your laptop or your node. So that is what is managed by kube proxy. So the kube proxy component will ensure that who can talk to whom is all managed by this kube proxy. So that way, by default it puts an entry in IP tables in terms that all the pods within this node can talk to each other. Tick mark. So then, if that rule is there in IP tables, then all pods can talk to each other. But that entry is managed by or created by kube proxy. Similarly, one node can it talk to other node? Yes, but because it's IP addresses, each node has an IP address also, right? Each node also has, it's nothing but a virtual machine. Even this virtual machine also will have an IP address. So this node can talk to this node, or this node can talk to this node. So that rule is also entered in IP tables. So every time when you make a network call, so first it will be checked in the IP tables to see whether there is a valid entry. If there is an entry and there is an approval, then this communication can happen. Otherwise, the communication will not happen. So that IP tables management is all done by this kube proxy. So summary, kube proxy is a networking component which associates an IP address, and also it gives information in terms of who can talk to whom. So pod can talk to another pod, or a node can talk to another node. So that information And also the services, for example, if you remember the load balancer that we added. So that is also one of the networking components. So that is also managed by this kubeproxy. So that is, in summary, that is a core networking component. Right? And of course, pods we know, we discussed this enough. So pods, there are multiple sizes. Pods can be a group of multiple container images and storage components. And then next one is this container engine. So this container box is nothing but your container engine. Of course, all this runs as a image, right? I mean, you deploy your container image. So for to run a container image, you need a container runtime engine. So and generally Docker is the most preferred container engine, but of course it is an optional component. You can replace Docker with something else also. Yeah, in addition to these are the minimum prerequisites in a node: kubelet, kubeproxy, pod, and container engine. But in addition to these four components, there are many add-ons. Add-ons are like optional components. So these are all optional components. Like it is not binary, but it is good, like a top-up you can add if you're interested. So few such add-ons are like UI. For example, Kubernetes has a UI component. I think I'll show you that UI component shortly. But Kubernetes also has a UI component. And also something called DNS. So let's say you're interested to use a domain naming service. So you can add the IP address. You can associate a domain. For example, let's say you want to give a name myservice dot. For example, myservice.com. So that is your domain name. So you want to associate the myservice.com/pod1/pod2/pod3. So likewise, you want to associate a DNS name. That is also possible. Again, this is an add-on that you need to add inside a node. So there are a lot of add-ons are there. I think this add-ons list is also growing very fastly based on the popularity and the usage. So there are a lot of add-ons for networking, a lot of add-ons to storage. So this add-ons is becoming like a marketplace now. So yeah, that's about the Kubernetes nodes. So any question before we move on to the next section? So in summary, there is a master. A master talks to multiple nodes, and the control plane makes a lot of decisions, and the node is the one which executes that decisions. But master decides what is the decision. So it will transfer that, to make the decision, pass the decision to the nodes, and nodes will ensure that decision that is set up is followed. So that's a concept. It's mostly a master slave or a control plane node architecture. Any questions here? Probably a lot of theory today, but I think but this theory is important for you to proceed further. So how internally Kubernetes talks to each other. So that is something that we need to know. If you don't have any further questions, I'll move on to the next section. Or yeah, any questions here? Or okay, I'll move on. So yeah, I think so far we saw a lot of command lines, right? If you remember this instructions, yeah. If you look at this, a lot of commands that we executed in the past, right? So we created a hello world container, and we executed create deployment, hello world API server, and we also exposed that via load balancer, and we could access that portal. So we saw a lot of kubectl commands, get pods, get deployments, get service, get events. So we saw a lot of kubectl commands in the prior demos, but you can also, I mean, generally it is good for, it is one simple service and it is easy to manage with the command line. But generally in organizations where they create multiple or even hundreds of thousands of such microservices they deploy generally for a project, it will definitely more than one microservice. So if you have such, and let's say database could be one service, it could be your API component could be one service, a UI component could be one service. So there will be a lot of multiple images that will be there in a, let's say, if they take a 3-tier architecture, there will be minimum three services will be there: UI service, API service, and a DB service. So here this is a hello world simple service, so we don't have such complexity, but generally there'll be multiple microservices will be there. So managing everything via command line is not easy. That's where there's something called they decided to create a configuration file, like a properties file, so that they can give all the inputs in a properties file or a configuration file, and they that that's where what language to I mean what format to use. Instead, they thought of JSON, but JSON has a lot of complexity. So YAML is one of the most popular. YAML stands for this. So reverse acronym of Ain't Markup Language. So this is YAML is one of the popular equivalent to JSON, for example. So JSON most people would have used. YAML also follows is similar to JSON. So it has a lot of advantages compared to JSON. So where in terms of the size is lesser, definitely compared to JSON. So and there's a lot of other advantages of representing some data in form of YAML. So YAML stands for Ain't Markup Language. So generally reverse acronym. So yeah, Kubernetes follows YAML as the standard format. So generally all your instructions you can also give it in form of a YAML file. So if you take YAML file is nothing but it has a key value pair. So I will just show you sample YAML file how this will look, but so you get an idea, and then I will show you. I will come back to this YAML file. So this is a sample YAML file, for example. This is how it will look. I mean, this is a sample deployment command that we executed before. Right in the, I mean, it's just replica of that. For example, kubectl create deployment. I'm creating a hello world REST API with image as this. So this is simple, but let's say if you have more properties, then you need to add hyphen like this. You can add hyphen. Additionally, you want to add additional parameters like, so you need to give some name here, so some value here. So name and value will be there. So name and then a value is what you generally use. For example, image is equal to. But here also you're actually following a key value pair. I mean here you're telling image is equal to it's a name, I mean key, sorry, and this is a value. So it's not name, it's key. So you're following the key value model. So but the same thing you can represent that in a YAML file also. So yeah, this is a sample YAML file how it will look like. So if you look at each one is a key and this is a value, key and value. So so this is how a YAML file will look like. And if you look at this indentation is very important here. I mean if you do this is following a different meaning. When this is like parent-child relationship, the selector is a parent and an app becomes a child of selector. But if you just give 2 lines, then the app will become a child of match labels. So that is the meaning of that. So this parent just like a tree hierarchy. But one space matters. The spacing is our indentation is very important in YAML file, and that's where most of us will make mistakes also. And we generally ignore the spaces and suddenly we deploy and something will fail. And so yeah, so that is a one drawback of this YAML file. So this indentation, of course, that's where this editors will help you handy. I will tell you what are this YAML editors that you can use also to make your life easy. So of course you can do this in Notepad also, but I think that's painful and you can make a lot of mistakes. But there are a lot of editors which in IntelliJ or any a lot of popular VS Code editors are also there, which can help you to beautify your YAML files, make it more friendly. Yeah, the summary is back. So YAML is is nothing but a configuration file. It is nothing but a name and a value. So if you let's go back to the YAML before we jump into this. YAML is a key value pair we just discussed. Like for example, fruit orange, vegetable carrot, meat chicken. So this is one just key value pair, and this very important thing is there is a space after the colon. So there's something we need to remember. So even here, if you see, there's a space after every colon. So this is also one important factor. Very generally we tend to ignore this, but this will also give some errors. So yeah, the space is important here, and also this indentation. So and also it has some data structures also. For example, it can use YAML has data structure. Let's say you want to use an array list. For example, imagine fruit. Fruit will have multiple fruits, like apple, orange, strawberry, mango, and you want to put it in an array list. So you use hyphen. So when you add hyphen before it in YAML, it says that it's an array list. Means it can hold many values inside this also. So, and it is also possible that it could be more than one value could be possible in that. When you see an hyphen, it means that at the same apple level, you can have multiple other aspects also, like because it's an array list. So orange, strawberry, or mango also can come at the same level of apple. So that is the meaning of array list here. The hyphen denotes that. And other data structure that you can use is dictionary. So dictionary or map. Map is very common. Dictionary is more popular for people with Python background. So map for .NET or Java, like map. Map is nothing but again a key value pair. So inside a hash, for example, take hash map. Right, hash map in Java will have a key value pair. So similar to that. So let's say you have a requirement to have a map. For example, an orange. If you are interested to show in orange what are the factors like carbs, fat, and calories, so you can have that organized like this. So yeah. So this so under one heading you'll have subheadings like this is the child of orange, child nodes of orange. Again, I'm just giving some basics. It's nothing to do with Kubernetes. I'm just giving you some YAML basics. There's nothing to do with Kubernetes. So. Yeah, here this is a complex thing that could be there. It's a combination. For example, the key value pair, dictionary, and list put together. For example, let's say the fruit. I'm just clubbing these two now. In fruits you have list, and let's say inside orange you have carbs like this. So I'm clubbing these two together to form this. Right. So fruits under apple so you have subcategories and orange subcategories. So yeah, this is how a complex. If at all a complex structure is this in YAML, so there's nothing beyond. So it's not. Then to understand the basics, it is pretty simple. Just organizing your data structure. That's all. Right? Any questions in YAML? Okay, I'm moving on. So next is this. Yeah, you can, as I said, like you can represent Kubernetes in the form of YAML, right? So the same whatever we saw earlier. So this is I'm depicting that here. For example, I'm just taking a notepad so that you easily understand this. So a YAML file, if you look at some hierarchies that you need to know by default. So something called API version. So blindly, if everything, if you have to create this from scratch, you need to know these four things. Okay, these are the minimum things that you will have in any YAML file in Kubernetes: API version, kind, metadata, and spec. So these are the four things that you need to remember in any deployment file. I'm just giving you this basics because, of course, there are a lot of editors which will, which they made this easier. You don't need to remember all these things, but generally, day in day out, when you see these YAML files of Kubernetes, you need to know what are the roles of each things. Right? If you want to change anything, you need to know first what does this perform. So what does this mean for in terms of Kubernetes? So that's why you need to know this, but the sequencing part, you don't need to worry. There are a lot of editors which can make your life easier. But just know the meaning of this value of this keys, so that if you want to change anything in future, you know, okay, you go and change this key. You change the value of this key, this thing will happen. So you'll be able to judge that. But don't worry about this such a big attribute, because this all editors like code editors like Eclipse or IntelliJ or a lot of VS Code. So these editors will take care of your burden by adding some plugins there. Right. So yeah. So these are four things.
So Kubernetes is teaching be kind to each other.
Is Kubernetes teaching?
Be kind to each other.
Be kind to each other. Yeah, that's true. Yeah. So this kind is a very important factor. I think this kind has various things like, I mean, we saw already some components already by now. So we know we saw deployment, right? So deployment is one kind, and also, for example, replica set is one kind. A pod could be a kind. So likewise, there are service is a kind. So a lot of components that sorry. Yeah, these are things that you will these things you need to know. For example, what are the various kinds? And I think, and we already know most of this. We already tried these commands, kubectl commands. So these kinds will, by looking at any YAML file, first thing you need to look at is what is this? I mean, what is the kind? Because the structure for a deployment, the YAML structure for a deployment, will be slightly different compared to a service or replica set or a pod. So first thing you need to know, first your eye should go to always kind. So what? Okay, we see YAML file. What is this YAML file for? Is it for deployment, or is it for replica set, or is it for pod or service? So that is what is this kind. So first thing, I should go to this kind. Then you'll frame a picture. Okay, this is deployment. Then these are the attributes that I expect in a deployment YAML file, and are they there? So that is how we start looking. So, and going back to API version, is again, this is primarily Kubernetes is changing every day, right? So this APIs are also evolving over a period of time. So they're all, so that's why there's, just to give the download compatibility, the APIs of Kubernetes, they also maintain versions. So V1 or V2, likewise you can add some versions here. So that's what this API version stands for. So at any given time, when you're creating this YAML file, you need to tell what API version are you using, right? And next is metadata. So metadata is from the name itself, it's just like it will have labels. So because we know what is the importance of labels now, right? Because service makes use of labels to identify what pod it should send traffic to. This is one of the very important aspect. Generally, metadata is an additional information, right? But here in Kubernetes, metadata plays a major role in identifying which object I should send traffic to, for example, in a service. So yeah, labels play a major role here in Kubernetes. So that's why you need to tell what is the labels. So again, now if you look at, we are splitting, we are creating a child component under metadata, and also a metadata can also have a name. So name and labels associate a metadata. So inside labels, of course, you can have n number of labels. So you can create a label app. I mean, this is all. I mean, this is not, Kubernetes is not telling you what tables to use. You're free to use what tables you want. So for example, app is in this case hello world. So, or it could be any name, for example. It could be even a Sham or a Na or a Srini or anything. So, and generally there is also tire, which is also most commonly used label. So, tire, which is generally, again, is a free text. You can keep whatever you want, but generally a front end. Generally, these are all common tires that you use, like backend. Is it a backend service or a front end service or a database service or whatever? So these are all various tires or tiers, what are they called? So these things you can associate. That's about labels. right? And then name is like you can give whatever name you want. Generally, it is good to follow standard some convention here, so it's easy to identify. So hello world, whatever. In this case, it's REST API, so I'm using that. But it could be anything. It could be if it's a UI component, it could be some UI hyphen UI, something like, so that can identify from the name what it is. And you use this name very frequently because name is something uniquely tells you by looking at when you say get pods or get deployments, the output that you get is it lists this name. So it is good to have a valid name so that you can recognize what it is by looking at the name. So um, yeah, then spec is where you are giving instructions to Kubernetes. What should be my replicas, and what is my pod name, and what is my image name for a pod. So all these things you tell in spec. Um, Again, the spec will have important aspects like replicas. Again, you need to remember all these things. I'm just giving you some um, just to be familiar with these keys. There are a lot of things. I mean, generally you copy paste most of it, so you need to remember the sequence. But only know the value the meaning of these keys. So selector and template. So these are the three things that you will be there under spec. So replicas is I'm talking about now specifically deployment. I'm going to deployment now because the replicas and pods and services will have a different. It could have minor changes here and there, but now we're talking about the deployment structure. So when you say deployment, you actually are deploying the pods, right? So this deployment will have instructions in terms of how many replicas of pods you need. So let's say I need, let's say the hello world pod instance. If you remember, we created 3 replicas. So we can increase that. I can edit this any given time to make it 6, for example. So it will create 6 instances. So the replicas is what is defined in spec. And selector is again it look at the labels. So when it is increasing the instances by 3 or 6, for example, so again to which pods this replica has to be associated, because a node will have multiple pods. Again, how will Kubernetes will identify which pods this replica has to be applied? Again, answer is labels. So it will look at labels and it will primarily look at match labels. So you're telling you apply these replicas. I mean, generally it is good practice to use 2 as the default space limiter, right? I mean, the selector under this selector, I'm just adding two spaces and then adding match labels. So when you apply this replica, to which replica I need to associate this, so I'm using match labels, and under that 1, 2. Again, the same name whatever I use here, so I'll bring that here. So I'm asking to apply this to this name, pod name. Okay, so that's about the selector, and of course template. Template is again this also will have the again labels in terms of at high level. This template will have metadata, and also it also has a spec inside. And the spec will have the spec is actually having your container information. So what containers you want to deploy. So this, for example, remember we gave this instruction of this hello world 001. So this is a container image that I want to install. So here since here if you look at here, hyphen is there, which means it is actually a list. So which means you can have more than in the same level you can have other sections also. So it is an array list. So that's why this, I mean, a deployment can have more than one pods. So So for example, here if you see this diagram, so you can have more than one pods, right? So this in a node you can have more than one pod. So you have more than one pods, then you will give all the details of what image one, under that image 2 and image 3 likewise. So you can add more images. In our case, it's only one image, so I'm just giving an array list of one. So sorry, space again here we should also follow space, and then yeah, what are the image name? So image name colon tag. The tag is the one which tells you what hyphen what is the version name. The tag, the image name and tag name will be linked here. And what is when you take an image, you can also add some optional components like image pull policy. So again, this all policy related stuff. I mean, how will you, let's say if the image is not there, what to do? So you can enforce some policies. So I'm telling image pull only if the image is not there. So if not present. So this means that you are giving instruction. This image is not already found in the node where this is getting executed. If the image is not there, then download that image and so pull that image. Okay. So that is what is instruction. And what is the name of your container? And this is your again matching this name. So this is how you define a deployment. So hope you understood what is generally a YAML file, how this will be. You mostly deal with YAML files. I mean, I just showed you this command line just to get you familiarized. But generally, I mean, the problem in this is that you have here. If you see, there are a lot of things you could provide information. If you have to provide all such informations, like it will become too big. I mean, here I didn't provide because it took some defaults. But if you have to give a full-fledged deployment, these are the so many things that you need to provide. Okay, and again, don't need to worry about all this. What will come below each. I mean, generally, no one will remember all this hierarchy. So you generally copy paste stuff in real time. We take some sample which is already there, and you can change some values. So yeah, just know what to change for a given scenario. That is what is important. So as long as you know that this hierarchy doesn't matter. You need to remember this hierarchy. So, yeah. So any questions here in this deployment or YAML structure? I will tell you how to run this YAML file inside when you're creating a Kubernetes YAML file. Once you create a YAML file, you import it into kubectl using a command called kubectl apply and -f, which is a file name, and as you're saying this file name as deployment.yaml, so you need to give that file name. So once you give this, then this instruction will be deployed into Kubernetes. So which means when it is deploying it, it looks at this keyword kind, and then it knows that it is a deployment object, and to look at what is your name, and also to look at what is your image. First, you download your image if it is not there, and then it will use this image, and also it will associate the labels to this image. So you do a get pod rs get pods kubectl get pods command. You can see this name listed, and also it also applies all these labels and stuff to that. So that's how Kubernetes works behind the scenes. Yeah. Right. That's about the Kubernetes YAML. I think let's also look at the service YAML. Service YAML is a bit simpler. Service YAML is again the kind is service and metadata. I mean, again, same standard stuff. I think you will start with all those four hierarchies first, right? So I think I'm just making it simple here. This kind. Sorry, this API version will start first. The standard 4. I mean, you should remember the standard 4 API, version, kind, metadata, and the spec. At any given time, when the deep sleep, if you are asked to tell what is the hierarchies, these are the 4 things you need to tell. So yeah, this API version, kind, metadata, spec, and under that, since we are talking about service here, so this becomes service. So this is, and of course, under this you will have labels. I'm not going to the details, which you can see here. So here you have all the labels stuff, and the spec. Here the spec will be different compared to what we saw in the deployment. The deployment will have spec in terms of the pod specific, because deployment is actually deploying the pods. So the spec for a deployment will be specific to a pod. Means in terms of what is a pod, means what is the container image, and what is the pod name, and what is how many replicas you need for a pod. It's all pod specific definition is what is there in the deployment spec. But when you come to service spec, so the name is a service, right? So it will have networking specific components. Like spec is service is a networking component. So we'll have networking specific terminologies in terms of what ports should be open. Again, what type of service it is. So all these things will be defined. For example, type is a load balancer. So this will have networking specific specification. So this will have in terms of the first thing. I mean, this is the hierarchy under this is ports, and it will have selector, and this is of course this is optional component, session affinity, and the fourth component is type. This type is very important. I think this type we'll see what are the various types within service in the next session. But in our case, if you remember, we applied load balancer as a type. Right? I'm just trying to mimic this command that we tried earlier. For example, we exposed this hello world deployment to run on port 8080 and with type as load balancer. So I'm just trying to this create a service. When it after executing this command, we ran get service. It listed the service name, and we got a URL where you could access that web application. So if you have to create this in a YAML, so here is where you tell the type as a load balancer. So if you remember, we also discussed there are other load balancers like other types in service. I will explain. I will cover it in the next session. So load balancer, node port, cluster IP, and external DNS. So these are the various types that you can have. So yeah, in your case, it is a load balancer. So yeah. Okay. And here in ports, especially, this is an array list again. Here there could be, it depends on how many containers you have. If you have multiple containers, there will be multiple ports section that will repeat. So that's why it is an array list. So there are multiple pods, then multiple ports also will apply. So again, I will explain this ports more in detail in the next section. But at a high level, that you need to remember is so this node will have, this ports will have a node port. I mean, if you are applying, if the type is it's applicable only if the type is of node port, then this node port will be applicable. Otherwise, this is not applicable. So node port, generally the node ports will be starting from 30,000 to 30,700 something. I don't remember the exact number, but 700 plus. So around this range is where you have the range of node ports. I will have a separate slide when we go to the services of various types. So we'll cover it there. But yeah, node port is something you need to keep in mind that it could range only from 30K to 37K. That's 30.7K. So yeah, so this studies, so this case you can mention some port within that 30K range, and here you will tell, let's say if you are interested to run this application port 8080. So it will tell port, and this protocol is something that is a lot of protocols that Kubernetes supports, but the TCP is most commonly used protocol. So you need to mention what is the protocol, and also what is the target port. Target port is the port where the container is exposed. So if you look at this port in everything will in a pod, we have something called port on the pod side, and the pod will have a container, right? So a container will have some port also, and this container specific port is called a target port. So basically, when you get a traffic, so if you go back to this diagram, so when you get a traffic, so each pod, I mean, if you talk in terms of ports are not mentioned here, but let's say you're interested in port 8080. If you're getting traffic on port 8080, then the traffic will go to this pod because of selector, and this pod, if you remember, this pod has has a container image inside. There's a container image inside a pod. There's nothing but Docker image. So even this one will also have a port. So you need to translate your outside port to inside port. That's called port forwarding. So the traffic outside port could be 8080. This inside port inside this container could be something else. Let's say some for 5000. Let's say I'm just giving an example. So 8080 port has to be translated to when it goes to traffic goes inside the container, it is probably the 5000. So this is something called so that's why it's called target port. So from source you're sending 8080, but internally it is translated to 5000. So that is what is this target port is. So as I sorry, it's going probably a bit deeper, but I think this we will when you see this real example, you'll understand this. So this port is an outside port, and target port is inside port. But this can be same or be different. So for example, this could be 5000 also, for example. So yeah, so that is about the ports, and also this selector is again labels. Whenever you see selectors or metadata, they both will have label information. So so this way. Yeah, this will again app and some name, hello world in this case. So then session affinity. Session affinity, if you want this traffic should be routed to only to this pod, then you are giving you can give requirements in terms of how the session has to be linked. Otherwise, default is none. And of course, we discuss the type, right? So that is how this YAML service structure will look like. So summary, in any YAML files, you have the main 4 pillars: API version, kind, metadata, spec. So that is applies to even both deployment as well as service. But the spec is what it is uniquely will generally change based on the object. And we call this as object, Kubernetes object. Deployment is an object, and the service is an object, Kubernetes object. So based on the Kubernetes object or a kind, this the spec section will vary, right? So that is what is this that you need to know. Probably I think we'll try to create a sample application in the next session, and let's use the same hello world example with a YAML based structure. Probably I think let's logically break here, and then we'll do this the next session. So probably I think I also wanted to cover up on the various services that are there. I think we saw here various service load balancer. So like this, we saw the various services like cluster IP, node port, load balancer, and external names. So these are some various ports, how this will look like. So probably I will cover up on that. Yeah. So I think a story, it will, I mean, it looks, it will look multiple like you're knowing many things, but at the end, but this is the basics. I mean, if you understand this, Kubernetes is evolving every day, just like cloud. So there could be here and there new tags or new labels that could be added, but it's just an incremental learning. But mostly the deployment service are the most commonly used. So I think if you understand these two structures well, then yeah, then replica set is one more is there. So probably we'll cover that on the next session. But I think deployment service, replica set. There's something called pod that also you can create. There's a YAML structure for pod also. But pod section is generally covered if, I mean, we use deployments because there will be more than one pods that will be installed. But you have just one pod. You can also create a Kubernetes YAML file for a pod. Kind will be pod here. But generally, kind of pod will be less used. Mostly, there will be multiple pods that you need to manage. So generally, you give deployment is where you cover all the pods here. This because also you get an array list here. So you create a lot of pods here. So yeah, then you'll have deployment and a service is most commonly used. Okay, I think let's logically break here unless you have I mean, if you have any doubts, we can discuss.
Yeah, I think it's good. The more the examples we see next week, probably it'll make more sense. Yeah.
Yes. I think, but I think today's I mean, a lot of theory, but I think it is. We actually went into the Kubernetes architecture and we understood.
Yeah. Today is like basic towards the practical. When you
Exactly.
go into practical, also it is kind of dry. That is one of the problem with these things. But if you one or two classes after this, it will be interesting. Yeah.
Exactly. I mean, I think if you see stuff in this theory part is as I said, it is a lot of things to cover. So that's why it is a bit dry. But I think once we look into the practicals, right, it will be very interesting. So probably I think we'll cover up more on the practicals in the next session. Probably let's create all these things in terms of YAML files and try to execute this the same thing whatever we tried before in terms of YAML files, so that you understand the power of YAML.
Yeah.
So yeah,
Sounds good, man. Yeah. Thank you. Yeah. See you.
thanks everyone. Bye bye.
So, thank you. Bye.
Bye bye.